Struggling with oxidation numbers and those mysterious Roman numerals and chemical names? Well, if you're an O-level, IGCSE, GCSE, or high school chem student, you are in the exact right place for this explainer. We're going to decode this secret language of chemistry together, and I promise you, it's actually incredibly easy once you know the trick.
So, let's start with a question you've probably asked yourself while staring at a past exam paper. Why is it called iron 2 chloride? Why can't we just call it iron chloride and call it a day? What is the actual point of that Roman numeral sitting right there in the middle of the name?
Well, check this out. We've got two formulas here, FeCl2 and FeCl3. Both are made entirely of iron and chlorine, but they are completely different substances. You see, transition metals like iron are kind of like shapeshifters. They can have more than one oxidation state. So those hidden Roman numerals, they're actually a crucial code telling us exactly which version of the metal we're dealing with.
Okay, let's dive into this. Today we're going to unpack oxidation states, look at the rules for oxidation numbers, calculate the unknowns, and finally name these compounds correctly.
First up, unpacking oxidation states.
At its core, chemistry is all about moving electrons around. An oxidation state, or oxidation number, they're the same thing, simply tells us the total number of electrons removed from or added to an element. That's it. It's just a bookkeeping system. If electrons are removed, the state is positive. If they're added, it's negative.
To really hammer this home, remember this rule. When electrons have been removed, the oxidation number increases. When electrons have been added, the oxidation number decreases. Since electrons carry a negative charge, losing them makes an atom more positive, so its oxidation number goes up. Gaining negative baggage makes the number drop. Conceptually linking positive numbers with electron loss is absolutely crucial here.
Moving on to Part 2, Rules for Oxidation Numbers. This brilliantly illustrates the official textbook rules you're going to need for your exams. Now, I know lists can look overwhelming, but they're incredibly logical. For example, free atoms in pure elements, like oxygen gas, always have an oxidation number of 0. They haven't lost or gained anything. For simple ions, it's literally just the charge. Sodium ion is +1, chloride is -1.
Let's break down a quick cheat sheet for you. Group 1 metals are always +1. Group 2 metals, always +2. Fluorine is the ultimate absolute. It is always -1, 0 exceptions. But you definitely need to watch out for the exceptions. Oxygen is almost always -2, except in peroxides. Hydrogen is almost always +1, except in metal hydrides. Prioritize those absolutes and exceptions and you will never get stuck.
Section 3. Calculating the unknowns.
Let's try a classic exam example, the permanganate ion, MnO4-. We need to find manganese. Step 1. Identify the knowns. We know oxygen is -2. Step 2. Set up the math. In an ion, everything adds up to the overall charge, which is -1. So, manganese is X, plus 4 oxygens at -2 equals -1. Step 3. Solve it. X minus 8 equals -1, meaning X is +7. Boom! Manganese has an oxidation state of +7. You just follow the algebra.
Finally, Section 4. Naming compounds correctly.
So, the crucial point is back to our original mystery. Why iron 2 versus iron 3? In FCl2, we've got 2 -1 chlorines for a total of -2. To be neutral, iron has to balance that out with a +2. So we name it iron 2 chloride. In FCl3, 3 chlorines give us -3. Iron balances it with a +3. Iron 3 chloride. The Roman numeral is literally just the oxidation number of the metal.
Let's solidify this with copper. Look at Cu2O. Oxygen is -2. To balance that, the two copper atoms have to share a +2 charge, meaning each individual copper is +1, copper 1 oxide. But in CuSO4, the whole sulfate ion is -2, so that single copper atom has to be +2, copper 2 sulfate. See how perfectly those Roman numerals distinguish the different states?
So here's your golden checklist to ace those exams. 1. Roman numerals show the metal's oxidation number. 2. They're written in brackets right after the metal's name. And 3. They distinguish compounds with different oxidation states, making everything clear and accurate.
Now, I'm going to leave you with a quick challenge. If you see the name chloric VII acid for the formula HClO4, can you mathematically prove why chlorine has a +7 oxidation state? Try setting up the equation right now using hydrogen as +1 and oxygen as -2. You've got this. Thanks for checking out this explainer, and good luck with your chemistry practice.